Have you ever encountered unexpected behavior while coding? It can be quite puzzling, right? If that's you, then you're in the right place. Today, we're diving into a Kotlin issue that has many developers scratching their heads. I totally get it. When you're experimenting with Kotlin and things don't work as expected, it can be frustrating. You're not alone in this. Many developers have faced similar situations, and it's completely normal to seek answers. Here's the specific question we're addressing today. One user asked, "Why does my Kotlin factory method return the same object?" They provided some code that shows two methods, one returning new instances and the other returning the same instance. Sound familiar? Let's explore this together. So what's happening here? The first method creates a new instance each time because it captures the current time in a closure. However, the second method returns the same instance. Let's break down why that is. And stick around. At the end, I'll share a key insight that will help you understand Kotlin's behavior even better. To understand why the user receives the same instance from the createTheSame method, let's first look at how this method is defined. The createTheSame method does not create a new instance each time it is called. In contrast, the createNew method creates a new instance of changeListener every time it is called. This is due to the closure capturing the current time when the method is invoked. Now let's examine the createTheSame method more closely. If the user wants to return the same instance, they need to store that instance in a variable and return it on subsequent calls. By implementing this change, the user will ensure that every call to createTheSame returns the same instance of changeListener, which is why they see true when comparing C and D. In summary, the user can control the behavior of their factory methods by managing instance creation. This allows for more predictable outcomes when using these methods. Fun fact, in Kotlin, functions are first-class citizens, which means they can be passed around just like objects. This flexibility can lead to some interesting behaviors, like the one we're discussing. Now let's look at the answers provided by other users. This user points out that the original code won't work as intended because the interface must be defined in Java for SAM constructors to be used. They explain that lambdas compile to anonymous classes, creating new instances when capturing variables. However, if no variables are captured, a single instance is reused for performance reasons. To ensure a new instance is returned each time, the user suggests using the full object notation. This allows for different instances on each call. Interestingly, IntelliJ may suggest converting this back to the SAM syntax, which would return the same instance. The user concludes that if instance comparison is necessary, using the full object notation is preferable. This allows for additional state, like an ID, to be added to each listener. Let's take a moment to review another user's answer. This user suggests that the behavior you're observing is due to SAM conversion with Kotlin interfaces. They explain that SAM conversions only work for interfaces, not abstract classes, and are specific to Java interop. To achieve the desired functionality, they recommend using object expressions instead. Here's a tip. When designing factory methods, be mindful of how you manage state. Understanding closures and instance management can save you a lot of headaches down the line. And there you have it. Now you understand why your Kotlin factory method behaves this way. Remember, understanding the nuances of the language can greatly improve your coding experience. If you found this helpful, hit that subscribe button for more insights.